Hello everyone, my name is Juan and I am the developer of qtfuzzylite, which is a fuzzy logic control application. So today what I'm going to do is I'm going to show you what qtfuzzylite is. I'll provide just a brief introduction to fuzzy logic control. I will go over some examples and finally I'll show you some demos of what qtfuzzylite is actually able to do. So what is qtfuzzylite? Well, it is a free open source application based on the Qt framework, and it links to FuzzyLite, a free open source C++ library to do fuzzy logic control. Both are available for Linux, Mac, Windows, and some other platforms as well. So, is it free? Well, yes, it is totally free. It is totally open source, and it is commercial friendly, so you can actually use it on your closed source applications without a problem. But please have in mind that I still have to pay for web hosting. I currently live under the conditions of a full-time PhD student. I would love to replace my 5-year-old MacBook, and I'm not even charging for my free time, so please consider making a donation via PayPal with whatever you can to support these projects. It will be mostly welcome. So, can you use fuzzy logic control? Well, if you have a system whose output depends on the inputs, and you can actually model the behavior of the whole system by a set of rules in the form of, well, if input A is X and input B is Y, then output is gonna be some Z term, then yes, fuzzy logic control might prove to be very helpful for you. The classic example of fuzzy logic control is the tipper example, which is how much money do you estimate to give as a tip in a restaurant, depending on the quality of the food and the service provided. So you have your inputs will be the food and the service, the quality of the food and the service, and the output will be how much tip you expect to give. So you can actually model this system by the following set of rules. Well, if the service was poor and the food is rancid, then the tip is gonna be cheap. If the service is good, then the tip will be average. And if the service is excellent or the food is delicious, then you expect the tip to be generous. Okay, so let's model the tipper example using qtfuzzylite. This is the interface of qtfuzzylite starting from version 2.5. And we're going to start adding the input service, which we're going to rate from 0 to 10, and we're going to the degrees of the quality, we're going to define them as poor, and we're going to utilize a Gaussian distribution of mean 2.5 and say standard deviation 1. And let's create multiple copies of this term, a couple of copies with a separation of 2.5, and the other terms we're going to name them good and excellent service. So we have the 3 of them, and there we have this is how we model the input service. We can actually edit and batch and delete the whole things, and you can actually, if you want, you can actually play with the divisions within the form. So now let's add food, and we're going to rate food from 0 to 10 as well, and the terms of food will be rancid, which we're going to define as using a ramp starting at 0.5 and ending at 0, and another term which will be delicious as the same hedge starting at 2.5. So we have our inputs. If we right click, we can actually have a look at what the inputs are and find out the fuzzy value for given the input. And let's add the output, which will be the tip. Let's keep it in the range 0 to 10 as well, and let's utilize basic triangles that go from 0 to 2.5 and 5, and let's create multiple copies. Let's create a couple of copies with separation 2.5, and the names will be service, average, and this is not service, this is tip. So the tip is gonna be average and generous. This term, the name was cheap. So we have the output tip. We're gonna be cheap between 0 and 2.5, and there you go. Now the default value, in case that the no rules are activated, we can actually set it to not a number, to 0 or to infinity, even if you want. Let's say minus infinity, and we're not going to log the value. What log means is that if the output is logged, then in case when no rules apply and there's no output to show, the last known valid value will be shown. But in this case, we just want to output the default minus infinite. So there we go. We have the inputs and the outputs. The next step is to create the rules. So in qtfuzzylite you can actually push this button and it will generate all the possible combinations, so all you have to do is just fill in the blanks. However, since we have a rather simple fuzzy system, we're going to do this by hand, and the rules that we're going to have are just, well, if service is poor or the food is rancid, then the tip is going to be cheap. That's rule number one. The other rule that will define the behavior will be, well, if the service is good, then the tip will be average, and finally, if the service is excellent or the food is delicious, then the tip is generous. So we parse the rules, hit it on the spell checking button, and we have no errors in the rules. In case you had a mistake, it will actually point out which mistake it was. So let's fix it, and so now we have the rules, and we can actually proceed to test the control of the engine. Now once we hit the control tab, we actually get to see the inputs, the outputs, the rules, and the strength to which each rule is activated given the input values. So now you can actually start changing the input values of the inputs. So say for a service which is quite poor, and according to the quality of the food, we can see how the tip is changing as we change the food quality. And moreover, you can actually see how the rules are activated, the strength to which each rule is activated. So that will define the output of the system. Additionally, you can actually play with the divisions of the form as well. So you can get rid of the rules of the inputs and outputs. You can actually just focus on one or the other. Now that you know how to create a fuzzy engine in qtfuzzylite, I'm going to talk a bit about the features of FuzzyLite, just the library itself. First, it is completely completely coded in C++, and it doesn't use any other library than the standard template library. So no boost is included, nothing else except what a standard installation of C++ would contain. It contains over a dozen terms to model the linguistic variables, also over a dozen fuzzy logic operators, and many examples to play with. These examples are mostly extracted from MATLAB and Octave, and we have created some of our own. Different differentiation methods, for example the bisector, the centroid, the maximum differentifiers, amongst others. Linguistic hedges, you can actually utilize like any vary somewhat in the rules. So for example, you would say if the food is very good, then the tip is very generous. As you just saw, the rules are just written naturally, so there's nothing much to it. We can actually import and export from and to different formats that I will show you later, and yeah, many more features that actually do not fit in this page. So let's start with the terms. Now the terms available in qtfuzzylite are the following. You can actually click on this button and it will give you a toolbox to play with. So the basic terms are the triangle, which you can actually scroll over its values or just input the value by hand. The trapezoid, the rectangle, the discrete membership function, which you can actually set the values by hand. Say 0.5. You can process it. We say 0.51, 0.75, 1, and 1, 0. So you can model pretty much any term you want by using pairs of x, y. Now, an extended set of terms are the Gaussian, which has a mean and a standard deviation, a Gaussian product of two Gaussian functions, the bell with center, width, and slope, the pi shape, so you can change all the parameters, the sigmoid difference between two sigmoid functions, the sigmoid product of two sigmoid functions, and a special toolbox is a special set of terms are the edges, which are the ones that you utilize to model the leftmost and rightmost parts of the linguistic variables. So you have a ramp, which you can change the direction by switching the start and the end parameters. The sigmoid function, which you can actually change to left and right according to the sign of the slope, the S shape, and the Z shape. So these are all the terms available in FuzzyLite 2.0 and 2.5, and I am also working on a few more which are actually quite interesting. The FuzzyLite library also allows you to import and export using different formats. So I'm going to import from a file which we created an example. It is ambient light and bulb power. So we actually want to control the how much light should a bulb emit given the ambient light. So we have some basic rules, nothing too crazy, and the control, as you see, it shows just a simple fuzzy control. Now in FuzzyLite you can actually export it to C++. Here, as you see, this is the code needed to create such an engine using the FuzzyLite library. So you create the engine, you add some hedges if you need, you create a variable, set the range, add the different terms. You add the variable, of course, the output variable, set the different terms, the different parameters of the output variable. You add the terms, and finally you create the rule block, which will have the different t norm and s norm, and you add the, and at last you add the fuzzy rules. FuzzyLite library actually allows you to use multiple rule blocks if you want, with different t norms and s norms and activation fuzzy logic operators. As you can see, it is really straightforward to create a fuzzy engine using FuzzyLite library. Now we can also export the engine to the fuzzy control language, which is in a specification for fuzzy control engines. So here you would have the output. Also, you can export it to the fuzzy inferences system format, which is the one that uses MATLAB and Octave. So here you have how it would look, the code on Octave or MATLAB. So I'm going to copy this text, and I'm going to show you how you can also import it from FuzzyLite. So here you would actually paste it, and let's modify some of the values. For example, here instead of a triangle, let's set a Gaussian membership function with standard deviation 0.25 and mean 0.5. Also notice that I use some specific parameters that are not standard in MATLAB. So yes, we're going to reset the current engine, and here you have how it would look changing the fuzzy inference system format. Well, now let's see the settings of a fuzzy engine. So I'm going to import the same we did before, and here you can see the how it behaves under the standard, the default parameters. Now let's see how changing the activation fuzzy operator, you can see how the output changes. Now if we change it to bounded difference, you can see how it behaves. Now the drastic product, which will be in this case activated, Einstein product, you see how different it is from the others, and the Hammersher product. Now let's set it back to minimum, and let's see how the accumulation methods behave. So this is the maximum one. Let's change it to algebraic sum, to bounded sum, to drastic sum, to Einstein sum, and finally the Hammersher sum. So as you see, the different operators provide different behavior for the fuzzy engine. So let's change back the accumulation method to maximum, and let's play a bit with the diffusifiers. The default diffusifier is the centroid. As you can see, the diffusified value is given by the dashed line, and the blue circles in the terms are the centroid of the figure. So you can see how the dashed line always matches the centroid. Now the bisector is a bit similar, but does not necessarily matches the centroid of the term. Now the largest of maximum, or rightmost diffusifier, goes to the maximum value of the largest value of the maximum term, as you can see. The other version would be the smallest, or leftmost the fuzzifier, which you can see the behavior, and the mean of maximum, which is just the mean between the mean and between the smallest and largest. So as you can see, there are the weighted average and the weighted sum, which are the fuzzifier for the Takagi-Sugeno rules, which will be available from FuzzyLite 3.0 onwards. I'm currently working on those. Now, regarding the divisions, it determines how many samples. It determines the integration of the output term. So the more divisions, the more accurate the output value will be, but it will also require more computational processing, so you have to balance this according to your requirements. Finally, in the hedges section, you actually will have to select all those hedges that you're going to use within the rules. Well, this provides a good summary of the main features of FuzzyLite. Remember that FuzzyLite is the library that does pretty much everything, whereas qtfuzzylite is just a front end based on Qt. Now, please consider making a donation to support these projects. As you can see, it is in active development, and there are still many things to do to improve it. So please, any donation with whatever you can afford will be mostly appreciated.
Thank you very much.